Imagine sending a tiny robot, Voyager One, into the unknown, a fragile messenger built by human hands, venturing farther than any object we've ever launched. It travels past the edge of our solar system, leaving behind the familiar warmth of the sun, and entering a realm where darkness reigns and the rules of space begin to change. For decades, Voyager One journeyed onward, sending back breathtaking glimpses of distant worlds, Jupiter's swirling storms, Saturn's icy rings, and the pale blue dot of Earth itself. Then, after nearly 4 decades, it reached the edge, a mysterious frontier where it encountered what scientists call a wall of fire. This isn't science fiction, but a real invisible barrier where temperatures soar to an astonishing 90,000 degrees Fahrenheit, far hotter than anything Voyager had faced before. Here, the sun's powerful winds crash into the cold, ancient winds of the galaxy, a cosmic battleground where two vast forces collide, creating a turbulent, glowing boundary. That temperature is nearly 10 times hotter than the sun's surface, yet somehow Voyager survived this inferno, continuing its mission against all odds. How is this possible? The answer lies in the difference between heat and temperature, a subtle but crucial truth of the universe. In this region, the particles are incredibly hot, but so sparse that they carry little heat, allowing Voyager to pass through unharmed. Scientists once expected a gentle transition at the solar system's edge, but Voyager found a violent, chaotic collision, a cosmic shockwave marking the true boundary of our home. This wall isn't just a scientific curiosity, it acts as a shield, a dramatic and dynamic boundary that protects our solar system from the harshest forces of interstellar space. It forces us to ask, what else is out there, lurking beyond this fiery threshold, if even our own edge is so extreme and unpredictable? Voyager's journey didn't just extend our reach into the cosmos, it expanded our imagination, challenging us to dream bigger and look farther than ever before. Even in the vast, silent void, there are invisible structures, magnetic fields, and profound mysteries waiting to be discovered, reminders that space is never truly empty. The Wall of Fire is more than a scientific puzzle. It marks humanity's first step into a much larger, more complex universe, filled with wonders and dangers we are only beginning to understand. We learned that the universe is rarely simple and always more spectacular, more surprising than we could ever predict from the safety of our own world. Voyager's crossing is a powerful reminder. The unknown is never empty, but brimming with secrets and possibilities. Our first step beyond the sun's reach revealed a universe more violent, more beautiful, and more mysterious than we ever imagined, and the journey has only just begun. Let's rewind to 1977, a time when space exploration was still in its golden age and the world watched in awe as humanity reached for the stars. That year, NASA launched Voyager One and Voyager Two, twin spacecraft designed for a daring grand tour of the outer planets, a mission unlike any before it. Taking advantage of a rare planetary alignment that happens only once every 176 years, the Voyagers used gravity assists to slingshot from Jupiter to Saturn, then on to Uranus and Neptune, covering vast distances at incredible speeds. Each spacecraft carried a golden record, a carefully crafted message in a bottle, filled with sounds and images from Earth, intended for any distant intelligence that might one day find it. The Voyagers sent back breathtaking close-ups of Jupiter's swirling storms, Saturn's majestic rings, and the mysterious blue worlds of Uranus and Neptune, revealing details never before seen by human eyes. Their discoveries transformed our understanding of the solar system, uncovering a complex ecosystem of worlds, each with its own unique features, atmospheres, and moons. But the Voyagers' journey didn't end with the planets. After completing their primary missions, they pressed onward, venturing into the vast unknown beyond the edge of our solar system. Their new mission became even more ambitious: to become the first human-made objects to leave the solar system and enter interstellar space, carrying humanity's hopes with them. As the sun shrank to a distant point of light, the Voyagers crossed into uncharted territory beyond Pluto, where no spacecraft had ever gone before. Billions of miles from home, Voyager One made a groundbreaking discovery: the Heliopause, a turbulent boundary where the solar wind meets the interstellar medium, sometimes called the Wall of Fire. These spacecraft became our eyes in the darkness, sending back data from the edge of the unknown and pushing the boundaries of exploration further than ever before. Their journey stands as a testament to human curiosity, ingenuity, and the relentless drive to explore, reminding us of what we can achieve when we dare to dream big. The golden records continue to drift through the cosmos, silent ambassadors of Earth, carrying our story, our music, and our greetings to the stars. The legacy of the Voyagers is not just in the images and data they sent back, but in the spirit of adventure and discovery they inspired, showing us how far we can go when we reach beyond our limits. Their odyssey set the stage for humanity's next leap into the stars, lighting the way for future explorers who will follow in their path, ever onward into the great unknown. What is this mysterious wall of fire that marks the very edge of our solar system? It's called the Heliopause, the invisible frontier where the sun's influence finally fades away, giving way to the vastness of interstellar space. The sun is constantly sending out a powerful stream of charged particles, known as the solar wind. This wind blows outward in all directions, forming a gigantic protective bubble around our solar system called the heliosphere. Beyond this bubble lies the interstellar medium, a vast, almost empty expanse filled with a thin mixture of plasma, gas, and cosmic dust drifting between the stars. The heliopause is the exact place where the outward push of the solar wind is balanced by the pressure of the interstellar medium. It's a cosmic standoff, a boundary that marks the end of the sun's direct influence. Here, the solar wind crashes into the interstellar plasma, slowing down abruptly and heating up to extreme temperatures, creating a turbulent and energetic region. It's not fire in the traditional sense, but rather a region of superheated, incredibly thin gas and plasma, glowing faintly in the darkness of space. The boundary isn't a solid wall, it's a chaotic, ever-changing transition zone that can be millions of miles thick, constantly shifting as solar and galactic forces interact. For centuries, humanity had no idea this boundary even existed. It was only through decades of exploration and scientific curiosity that we began to suspect its presence. The Voyager spacecraft, launched in the late 1970s, became our first messenger to actually cross this frontier, revealing the violent and beautiful nature of the heliopause. The heliopause acts as a shield for our solar system, deflecting much of the dangerous galactic radiation that constantly bombards the galaxy, helping to protect life on Earth. It's a place of constant struggle, where the forces from our sun and the galaxy beyond are locked in a never-ending battle for dominance. The discovery of the heliopause completely redefined our understanding of the sun's true reach and the boundaries of our cosmic neighborhood. This so-called wall of fire is not fixed. It's a dynamic, ever-shifting boundary, responding to changes in both the solar wind and the interstellar medium. Only by sending spacecraft like Voyager across this invisible line did we finally learn the true nature of our solar system's edge. Thanks to Voyager's data, we've pulled back the curtain on a cosmic battle at the edge of our home, a battle we never even knew was raging until now. 90,000 degrees Fahrenheit at the edge of the solar system. How is that possible? The secret is the difference between temperature and heat. Temperature measures how fast particles move. Heat is about how much energy is transferred. At the heliopause, particles move incredibly fast, so the temperature is high. But the plasma is so thin, almost a vacuum, that there's almost no heat to transfer. Like a spark that's hot but harmless, the wall of fire can't burn a spacecraft. An astronaut would freeze, not burn in this region. The paradox screaming hot particles, but too few to matter. Voyager survived because the danger wasn't heat, but something else entirely. The wall of fire is a lesson in the strange physics of space. The real threat beyond the heliopause isn't heat, it's radiation. Inside the heliosphere, the sun's magnetic field shields us from deadly galactic cosmic rays. Cross the boundary, and that shield vanishes. Voyager One detected a sudden spike in cosmic rays after crossing the heliopause. For robots, this means potential glitches and failures. For humans, it's far worse. Galactic radiation can shred DNA, cause cancer, and damage the nervous system. Future interstellar missions will need revolutionary shielding, perhaps even artificial magnetic fields. The wall of fire marks the start of a cosmic shooting gallery. Crossing it means entering a far more hostile environment. Voyager's data is a warning. The dangers of deep space are real and relentless. Any journey beyond the sun's protection will demand new technology and courage. How did Voyager 1 survive the wall of fire? The plasma was too thin to burn it. The real challenge was radiation. Voyager was built tough, Designed to withstand Jupiter's harsh radiation belts, its shielded electronics and redundant systems proved resilient. The crossing wasn't a single leap. Voyager dipped in and out as the boundary shifted. This gave scientists a detailed look at the Heliopause's structure. Voyager's survival proved interstellar travel is possible for our machines. It set a baseline for future missions. What it takes to leave the sun's nest. The probe's journey turned theory into engineering reality. Voyager mapped the trail, showing us both the dangers and the possibilities. Its success is a monument to human foresight and ingenuity. Voyager's power is fading, but its discoveries inspire new missions. The next generation of probes will be faster, smarter, and built for the interstellar environment. Speed is key. Voyager would take 75,000 years to reach the nearest star. Scientists are exploring solar sails and laser propulsion to reach a fraction of light speed. Future probes will carry advanced instruments to study the interstellar medium in detail. They'll analyze plasma, map magnetic fields, and study cosmic dust. The seeds of new worlds. These missions will answer questions Voyager could only raise. The leap into the galactic ocean is the next step for humanity's robotic explorers. Each mission builds on the last, pushing our reach ever farther. The torch of curiosity passes to a new generation, venturing into true deep space. One bold idea, a dedicated interstellar probe designed to travel 100 billion miles from the sun in under 50 years. It would launch on a powerful rocket, then slingshot around the sun for a massive speed boost. A robust heat shield would protect it during its close solar pass. Its instruments would be direct descendants of Voyager's, but far more advanced. The probe could finally image our heliosphere from the outside, revealing its true shape. It would sample interstellar material, searching for clues to life's origins. This mission would span generations, launched by one and completed by the next. An interstellar probe would be a quantum leap, our first true journey into the galaxy. Why does the wall of fire matter? It changes our perspective. For millennia, we lived inside a cosmic cocoon, unaware of the ocean beyond. The heliopause marks the boundary of our home, our solar system's shield. Understanding it is crucial for knowing how our system protects life. The discovery is a lesson in humility. The universe is more complex and beautiful than we imagined. It fuels our curiosity and drives us to keep exploring. Voyager's journey is about the future, about humanity's destiny as explorers. One day, we may need to venture beyond the sun's protection. Knowing the challenges ahead is the first step to overcoming them. Voyager's crossing was not an end, but the beginning of our journey to the stars.